Hi, sixth grade. This last video on volume is going to be about finding the volume of an irregular solid. And so what we mean by finding the volume of an irregular solid, or what we mean by an irregular solid, is something that we can't easily find the length, width, and height of. So this round object here would be considered an irregular solid. My food coloring bottle, irregular solid, because we're not going to have just one length, one width, and one height. So you're actually going to have to take some of the information that you've learned on using graduated cylinders and finding the volume of a liquid and put it together in order to find the volume of an irregular solid. So believe it or not, we are actually going to be starting off with a graduated cylinder. So we want to fill, and I'm just going to abbreviate graduated cylinder GC. So fill the GC with enough water to cover the object. So there's not like a specific amount. It doesn't really matter what number you start off with. So I just kind of usually hold my object up here. So it looks like I'm just going to fill it to like 15 milliliters would be enough to kind of cover this object. And so this is where you would use your pipette as well to kind of get an exact measurement here. I'm going to try to do this. Remember, you need to be doing this on a flat surface, but I'm going to do this so you can see what's going on with my webcam. So I have 15 milliliters of water in there. So we're actually going to be using a formula for this one. And what it is we do volume, and then I just always put a little subscript of the letter that I'm trying to find. So we're just going to put B for ball because that's what I'm trying to find. And how I did that, the shortcut to get the subscript is Control, comma. So that's how you do that. Equals, and we're going to do our volume 2 minus our volume 1. So again, I come down to my next step. Volume 2 would be the second volume that we're taking. Right now, this is the first volume that we're finding. It's the volume of our water by itself. And so I know that I started off with 15 milliliters of water. So that's my volume 1. See how I'm subbing it in right underneath there. Now, how I get my volume 2 is I'm carefully going to drop this item into my graduated cylinder. So I'm going to kind of angle it. I don't want to splash my, oh, I didn't think about this. My ball is floating. Let me go get a marble. Okay, so I have my marble here. I'm going to carefully roll it down in there. So once I dropped that item into my graduated cylinder, you're going to see that that level water actually rose because the marble is displacing the water. So it's pushing the water out of the way. And the amount of water that's getting pushed out of the way is equal to how much space that marble is taking up. And remember, volume's measuring space. So if we can figure out how much water that this marble pushed up, we can figure out the volume of the marble. And that's why we're doing a subtraction, because we're trying to figure out the difference between the amount of water that we started with and then the amount of water that was pushed out of the way. So if I get my volume here, it's going up 2 milliliters. So we're at 17 milliliters now. Remember, you would have done that on a flat surface so that you could get at eye level. I made sure that that was level there. So our second volume, or V2, is 17 milliliters. See how I fit that into my formula? So I'm just substituting it in for this variable here. So my second volume was 17, and then all I have to do is just subtract. 17 minus 15 is 2. Now, we know that we use units milliliters for liquid, but we're not actually finding the volume of the liquid now. Once we've subtracted, we found out how much space that marble was actually taking up. So we're talking about a solid. And the units that we use for volume of a solid would be centimeters cubed. Why we can just flip-flop our units like this is because of our conversion factor. And I know that you guys have been converting units with Mrs. Signs. And this conversion factor is so super easy. 1 milliliter is the same as 1 centimeter cubed. So we can use milliliters and centimeters cubed interchangeably because it's a 1-to-1 ratio. So that's why we kind of flip our units here. So up here, we were finding the volumes of the liquids, but once we subtracted them, we were actually finding the volume of a solid, which is why we changed that unit. So the units that we're going to be using are going to be milliliters first, and then changing it to the centimeters cubed. And then our tools that we're going to be using are just our graduated cylinder. So if we go through these steps one more time, what I did, the first thing that I did was fill the graduated cylinder with enough water to cover the object. And I want to determine the volume of the liquid that I put into that graduated cylinder. I'm going to carefully drop my object into the graduated cylinder and determine the new volume of the liquid. Then I want to subtract the original volume of the liquid, so that was my V1 that I put in over here, from the new volume, or the second volume, and that was my V2 over here. So this number is the volume of the object. Okay, and so that finishes out your notes here. You're going to do 2 practice problems, actually finding the volume of different irregular solids. And then you guys will do some just review over finding volumes of all of these different objects. So I know finding the volume of an irregular solid is probably the most difficult. So if you do have questions, make sure that you're making an appointment to conference with me. So just to help get you started with the next step onto your to-do list, I'm going to kind of continue on with this video. So you just completed step 15, taking your video notes over finding the volume of an irregular solid, and you were supposed to add that onto the graphic organizer, so that would have been that third section on the bottom of that paper that you needed to complete. And then what we're going to do now is you need to get out your determining the volume of an irregular solid. So that's this paper here that you should have filled out. You've already done regular solid and liquid. So we're going to do that last page here. So I'm just going to do an example of a problem with you. So if you want to pause the video and go get that out, you can. So on the back counter, there are a whole bunch of different sized graduated cylinders. I just pulled one of them. How you decide what graduated cylinder you want is really based on the size of your item. So if I was trying to find the volume of my stapler, this graduated cylinder probably, well, that might work. Need a big object. Okay, so my tape. This graduated cylinder wouldn't be a good choice because the tape is too big to fit into the graduated cylinder. So you really want to kind of keep that in mind when you're choosing the correct size. So you'll see a whole variety of sizes over there. You want to choose a graduated cylinder that your item's easily going to be able to slide in and out of. Getting it out is the really important piece. So you're going to have to find the volume of a rock, a weight, and a marble. If you want to just come down to the bottom, you can do the example that I'm going to do with you right now. So I just like to write down what my first volume is and my second volume, just to help keep me organized. Some people prefer to go straight into the formula, and that's fine too. It's really up to you guys how you want to work. What I'm really looking for is the formula. So I get you started with the formula up here, and then you have to fill it in. And then on the weight and the marble ones, I expect you to show your formula work correctly. Okay, so for this one over here, so my first volume that I'm going to find, I'm just going to fill up my graduated cylinder with enough water to cover my item. So I just have this mineral that I'm going to try to find the volume of. You want to use your pipette to get an exact amount of water. So I want the water going to one line. So I just chose to make it exactly 200 milliliters. So my first volume was 200 milliliters. So I would fill that in there. And then I'm going to drop my item in, and notice how I carefully talked about this just in a second, but I want to show you with an actual item that's similar to yours. So then I put it in and that water gets pushed up. So then I'm going to read my second one up to 220. So I'm just going to fill that in here. Now notice that I'm still finding the volume of the water, so the units that I'm using behind my numbers are going to be milliliters still. Then I'm going to come over here and I'm going to actually write out my formula. So I'm finding the volume of a mineral, so that's why I put M there. And then I'm going to write what formula I'm using. This is where a lot of people make their mistake. We want to say that it's V2 minus V1. And then oops. Make sure that my equal signs are lined up. And now I'm just going to look at my numbers over here and I just have to sub them correctly into my formula. So V2 was 220 milliliters and V1 was 200 milliliters. And now I just need to subtract those. And I show my answer on my third line. So 220 minus 200 is 20. And then now that I've subtracted it, I've actually found the volume of the mineral itself, which is a solid. And we talked about in the video notes just earlier that 1 milliliter is equal to 1 centimeters cubed. So I can switch between those units really easily and don't have to really do any math whatsoever. So I'm just going to switch my units to be centimeters cubed then. So this is what your work should be looking like for this whole last page. Like I said, all of your items are on the back counter, so make sure that you use those. You can choose to use any graduated cylinder that's back in that section. Remember, for the rock, I went ahead and set up the formula for you and to kind of remind you that you should have your second step where you sub your numbers in and then your third step with your answer. But then for the weight and the marble, I don't give you those formulas, and you guys actually need to do that work completely because that's what it's going to look like on a quiz. Okay, so if you have any questions, please make sure that you let me know. Other than that, you guys can go ahead and get started with this activity.